In today's class, we will be discussing a question under the cloud computing concepts. Doing a tutorial class. So I will be writing a question in this whiteboard. You can take the question down, and once you you can have written down the question. So maybe you can first write down the question and then provide the answer in a separate sheet or something. I actually do not need you to submit this. So this is for your preparation to the final exam actually. So the tutorial questions I will be doing to prepare you for the end exam and also to give you an idea how a question will be formed under that specific category. So this tutorial will be based on cloud computing. So we discussed about cloud computing in the last class. We discussed about how cloud computing can be used for IoT applications. So specifically, once you take IoT applications, we have large volumes of data that we collect from our IoT sensors. These large volumes of data might not be we will not be able to store them in our local devices. So because of that, we need to send or transmit the data from the sensor node level to the processing units in the cloud. So large volumes of data is one of the features of IoT. And sometimes based on the IoT application, we need to have low latency in our applications. So we need to provide information as soon as possible to the customers who's accessing or who's using this IoT service or application that we are providing. So we need to have low latency, or we need to have real-time updates. Apart from that, we also might need to analyze the data and give useful information. So likewise, we have different requirements when we come when we talk about the IoT applications. We also want to maintain the security of the data security and authentication, data security and privacy. So there's a difference between security and privacy. So in security, what we mean is the security of data. That means data not being tampered by external parties. So maybe hacking of data, and then the data being modified, deleted by somebody in once the data is getting transmitted along the networks. So once we are actually using the internet to send our data can get modified or deleted by some intermediate parties. So once we face such situations, the security of the data is at a risk, and we need to maintain the security of the data by including encryption, decryption methods, and making sure that those methods work well for our application. So security means like our data getting tampered, changed by some intermediate party who is not authorized to access our data. So Privacy means like whether whether we allow our customers only, I mean, to access our system. That means like the we need to have a separate username and passwords for our customers to access the system and access their own data. So, so in that case, the users who are like who are the other users cannot enter the system without proper username and password. They cannot view the information of other users. So anyway, with all these features, we need to include IoT in cloud computing. We need to have both IoT and cloud computing services to increase the performance of the IoT system. So in this tutorial, we want to include the cloud computing capabilities into IoT system, and we want to see what is the best method of doing the computing. So this is basically, so I discussed basically regarding the IoT and what are the requirements of IoT networks. So now we will see how cloud computing can enable us to achieve those specific requirements of the IoT networks. So in here I have mentioned about cloud computing. Although cloud computing is mainly used for IoT applications, cloud is not the only method of doing computations as of now. We have other methods of computations as well. So we'll be talking about those approaches of computing as well, and we will decide what is the best method of computing or best approach of computing based on the application that we consider, right? So the cloud right? So cloud, fog, and edge. Let's say cloud, fog, and edge. So these three types of computing, three methods of computing are basically different based on the location where the data is stored. Where location of data processing. So, in cloud computing, cloud servers at the cloud servers. So the cloud servers are basically available in data centers. Uh, uh, Please wait a second. Okay, so let's resume. Based on the location that the data processing is done, computing is divided into three categories: cloud computing, fog computing, and edge computing. So in cloud computing, you are doing the computation in the cloud servers. So the cloud servers are basically available in the data centers. So the data centers are available in like specific locations in the world. For example, we have like in US and in other kind of countries with a lot of with available resources, uh, they provide the data centers, the services of data centers. So those cloud providers are located in specific countries or specific locations, which might be too far away for our application. So once the data transmission happens from IoT sensors to the cloud servers, there could be a significant delay in the data transmission. In that case, the cloud computing could not be the optimal method to store our data and do the necessary processing of our data. So cloud computing is done in cloud servers, basically. And then fog computing is done in an intermediate location between the location of collecting data and processing the data and the cloud service. Okay, so if you have any questions, you can ask. Right? I mentioned about fog computing in the lecture as well. So fog computing is done in an intermediate location between the edge computing location and the cloud computing location. So if the cloud computing is done at the data centers and edge computing is done at the edge servers, fog computing is done in an intermediate server in between the in the path of doing the transmission of the data, right? So once we are sending some data from the IoT network, from the IoT sensors and base network, our data will get transmitted through a certain path towards the cloud servers. So during that intermediate in that path, there could be an intermediate server. So that intermediate server will do the computation. So in that scenario, the computation done is known as fog computing. So it is done by a fog server. Fog server is also useful to us because sometimes rather than sending all the data to the cloud server, we can do some part of the computation or the total computation in the intermediate location. So with that, actually, we have that computing in the intermediate node. So the third type of computing is edge computing. So edge computing is defined for the edge of the network, right? So edge of the network, you might ask, what is the edge of the network, right? So you know that IoT sensors are connected to our IoT sensors and the base node is connected to a certain base station or an access point, right? So we call this entire boundary of the access point and the sensor nodes as the network edge. That means the location where we are able to collect the data as close as possible to the sensors is known as the network edge, actually. So the edge is the point where we are able to collect the data from the sensors. So so the sensors plus the application at the edge is included in this network edge. So network edge is actually components in it, so elements in it. So we will have the IoT sensors which are collecting the data from the environment and transmitting it to the edge server. So edge server could be installed in the access point. So the edge server corresponding to that. So if the access point is a base station, the base station will have edge server installed in it. If the access point is a router, then the router will be connected to a server. So have a certain edge server at the access point. So access point could be base station, it could be Wi-Fi router, and so the server which is connected to the router or the will be some server connected to the router, and that will be known as the edge server if the router is the access point. If the base station is the access point, there will be a server which is installed in the baseband unit, which is connected to the base station, right? We have some control unit that is connected to the base station. In that control unit, we can install the server. So that server is called as the edge server. So so this kind of servers, edge servers, can do the computation at the edge of the IoT network. Edge of the network means as close as possible to the devices that we are connecting connecting our access point with. So, if it is an IoT application, the sensor nodes connect to the edge server, and that edge is known as that uh, periphery of the access point at the server, and the sensor nodes is known as the network edge. So the computation done at the edge server is known as the edge computing. So those are the three types of basic computations, the computing types we have for the once we take the computing. And so once we take IoT applications, we can consider all these three types of computations. So, so today we'll be discussing the tutorial question that uh, we will be discussing to prepare for the end exam. That's one reason. Apart from that, I think this will improve your knowledge regarding computations, regarding about main types of computing. So, so I invite you to write the questions on your own as well, so that you can, if I need to erase, having the question in your papers, right? So we are going to be considering a certain scenario for this question. So if my writing is not clear, please let me know. So I hope you have marked your attendance in the attendance tool, right? I will check it whether you have marked it as well. So if you have any problems related to that, please let me know. Okay, so only 2 students have marked their attendance as I can see, right? So I think there are 6 students in this meeting. So if you have any problems, let me know. Only students attendance is marked in here. So please mark your attendance before 30 minutes past the lecture initiation time. Okay, so it will expire after the 30 minutes. I have already put the code in the chat. Can't you see that? Oh, I have you. I don't send the code individually to each student. The code is given in the chat. Is it okay or not? Right. So please let me know if you can't see the code. Right. So I will be writing. You can't see the code. I have sent the code to the, in the chat. You can't see that? So anyway, I will share with you. Some can see, some can't see. What is the, I can't understand what is happening actually. Okay, so I will share with you if you want the screen, the my of my uh, no, I can't share it. I think I just have the yeah. This is I will share the screen for you just to see. If you want, you can take a screenshot of this. Okay, now you can see the screen. So please take a screenshot and take the code, right? Uh, so I will be starting the lecture, I mean, really early. So you need to actually also attend the class at that time. So that is why I think I have, you have now you can get the code. So I will, right? I will go to my usual screen. So in the meantime, you can mark your attendance. So normally within 5 minutes of my class starting, I will be sharing my code. So that is why I had to put the code at that time. And this I will be talking about a scenario. So in here, consider that uh, you are an right at a company that uh, which operates a large fleet of vehicles equipped with IoT sensors. Okay, so these sensors track the location and track location, monitor fuel consumption, and etc. Okay, so these sensors are used to track the location of vehicles, fuel consumption, etc. So the goal of the company, the goal is to uh, use potential, IoT and computing technologies so your task is to design a specific computing solution for the application you choose, right? So your task is to design a specific type of computing solution for for the application you choose, right? For the application you choose. So there are different applications that we can choose. We are considering an IoT network of vehicles. So different vehicles are monitored. So we have a selection of vehicles. So let's assume this is like Uber or Pick Me or something. So we need to monitor the like condition of these vehicles, right? There could be cars and there could be different kind of vehicles, motorcycles and lorries or something, vans. So we, based on the different application, we are using different vehicles, right? So let's assume we have a collection of vehicles. So we need to monitor some features of these vehicles, right? So we can consider three main applications. One application that we can consider is tracking their location. We can track their location. Uh, that is one application that we can consider. Second application that we can consider could be monitoring their fuel efficiency, right? So you know that vehicles have fuel problems, and if the fuel is run out, we need to supply the fuel on time. Also, we need to monitor their condition, like we need to we need to monitor and maintain the vehicles. So maintaining the vehicles and making sure that the vehicles are not having like critical issues is one of the applications. So these three are the main applications that we are going to consider, right? So based on that you choose, you need to choose what is the best computing method that you need to use. So there are three basic computing methods, as I mentioned before. So cloud computing, fog, and edge computing. So you can choose the best method of computing depending on your application. Okay. So the first question is that choose a specific application. Choose sorry, choose one of the choose an application out of the following. So one application is location tracking. Second application is fuel efficiency monitoring. Third one is predictive maintenance. Right? So out of these three applications, you can choose one of the applications, right? Either you can track the location of the vehicles. Either you can you can predict the maintenance that is required for the vehicle. Okay, so if you have any questions regarding that, let me know. Okay. So I mean predictive maintenance, if you want further idea. So basically like when we have a vehicle, we need to go to a service station and like service the vehicle, right? We need to perform a maintenance check. We need to check its components. We need to renew its maintenance. To predict the time that we need to do the maintenance. So that prediction will be done under this predictive maintenance. Right. So depending on the application, so you can choose an application out of the following. You need to clearly define, right? First, you need to choose an application out of the following. Then, right, so after these 3 points, then you need to clearly define the objectives and the requirements of the selected application. Okay, so you need to define the objectives and the requirements of the selected application. Okay, so the objective of location tracking, for example, you need to mention what are the objectives of that application. Why do we need to do location tracking? What is the objective? And the requirements of the selected application. What are the required sensors, for example, required sensors, technologies for that application, right? For location tracking, what are the equipments we need? What are the things we need to install in the vehicles? What are the equipments we need to have on our side at the, for example, at the edge of the network? You can mention the requirements and the objectives of the specific application, right? So that is the first question, right? Yeah, defining the objectives and requirements of the selected application, right? So I'm going to erase this page, right? Then I'm going to talk about the next question. So you can take a screenshot or if you like, uh, and so that I can erase this page. Okay. I will erase this page. Then we need to evaluate the possibility of using the any specific type of computing, right? So the second question is we evaluate the possibility of using cloud computing, edge computing, and fog computing. For this application. Right? So we need to evaluate the possibility of using these three types of computing methods for this application, right? So in evaluation, what I mean is that you need to discuss the advantages and disadvantages of each approach. So basically, if you can do this, that will be sufficient. If you can, so what you need to do is we need to discuss the advantages and disadvantages of each approach. Of each computing approach, right? So you know that as I mentioned about the computing approaches, uh, there are like some disadvantages in cloud computing as well, right? Although it is very computationally efficient, the latency that is incurred in cloud computing can be higher than edge computing. Edge computing might be able to do some quick processing and then give back the decision very quickly. But it might not be able to do processing very fast. It might not have the resources to do very good processing of the data, but it will be able to give decisions very quickly back to the users, back to the IoT devices or the clients. So in this second question, you need to evaluate each of the computing methods, and you need to discuss what are the advantages and disadvantages of each computing type. Then thirdly, I have this question: establish a selection criteria to select the best computing solution. Okay, so in here you need to establish a criteria, right? You need to establish a criteria that define what is the best method, but best computing method for your application, right? So based on your application, you need to decide the criteria, right? So if you use a location tracking criteria, location tracking application, so for that specific application, what are the criteria that you require, right? So you can consider several factors for this. So consider several factors such as data processing capability, storage, right? Data store real-time updates, network connectivity, data privacy, cost for implementation of the network of the IoT system, resource availability, right? So these are some of the main factors that you can consider uh, when you are selecting the best computing technology for your application, right? So sometimes, like, you might, based in your scenario, you might not need real-time updates. You might so in your situation, it might be okay to have higher latency. In that case, you might not need real-time updates. It's okay to have updates after some time. So in that case, you need to you can decide whether you need real-time updates or not. Apart from that, based on the amount of data that you have in your system, you can decide whether you need high storage or low storage, likewise. So based on your application, you need to decide what is the data processing capability, what is the storage requirement, what is the real-time update required, whether it's required or not, what is the network connectivity you require, whether we require high amount of massive connectivity or we require only small amount of connectivity. That means only small number of devices are connected to your network. And what is the data security and privacy that is required? Do we need to secure the data, or is it not that necessary? And also the cost of implementation of the system, whether the cost of the system is very high when we consider cloud computing as well, or can we go ahead with edge computing only and we can reduce the cost? And apart from that, resource availability, like whether the resources are available for us to uh, whether the resources are enough for us to do cloud computing. I mean, what are the resources required, whether resources are available for us, and so on. So you can consider these factors and create a selection criteria that allow you to select the best computing method for your system. So this is basically the second and third questions, right? So I will erase this questions as well, right? So next we have the next fourth question, which is choose the most appropriate computing method. Choose the most appropriate computing method based on your evaluation and selection criteria. Based on your evaluation in number 2, second question in question 2 and the selection criteria in question number 3. Right? So then also give reasons why your action is aligning with your objectives and requirements. With your objectives and requirements defined in question number 1. Right, so you define some requirements and objectives in question number 1. So you need to verify and you need to justify that whatever the computing method you have chosen is aligning with the objectives and the requirements that you have mentioned in the question number 1, right? You need to mention that the computing method that you have selected is suitable to achieve the objectives and requirements mentioned in the question 1. Finally, you need to draw the diagram of the entire, draw a diagram of the overall view. Overall view of the IoT system with all relevant components. So each component clearly. Okay, so that is about it for the question system diagram, and you need to label each of the components clearly. So the sensors, the access point, the maybe some routers and switches that are in the where the computing happens, right? Computing location, the computing server. You need to mention. So these components you need to like clearly mention. So in the diagram, you need to label and show the components. Okay, so that's about it for the tutorial question. So you can try these questions, and you can let me know if you have any questions related to that. Okay. Apart from that, if you have any questions related to the IoT project, please you can let me know now. I will stop recording this.